Hello and welcome to our Sphinx Whitespace project video overview. My name is Curtis Main, and along with my teammates Zafar Siddiqui and Nick Giranda, we worked together to fix a whitespace issue in the free and open source software Sphinx, a documentation generator. As computer science students at Loyola University Chicago, we took on this project as part of our summer course on free and open source software under the direction of our professor, George Theravadikal. During this presentation, we will be covering the problem with a short intro, giving a brief overview of both Sphinx and Python, discussing free and open source software and teamwork, how Sphinx works, how we approached and fixed this issue, along with challenges and benefits of free and open source software for our conclusion. So let's get started. Sphinx was originally created to be a documentation generator for Python programming language. An issue that our professors, Dr. Theravadikal and Dr. Harrington, found and wanted fixed involves leading whitespace when line numbers are provided with Python code that has indentation. This is the original posting that Dr. Theravadikal made on our Facebook course page, where he asked students if anyone is interested in both Python and Sphinx and fixing this leading whitespace problem. Here is an example of the issue. If you look at the arrow, there's space between the line numbers and the actual Python code lines. This space could be a tab, it could be several spaces. The problem is the start of each Python code line is not up closer to the line numbers. This leading whitespace was not chosen by the user, but was generated during output for HTML. If we actually go to the problem and highlight the output in HTML, we can see that it literally is 4 spaces. So 1, 2, 3, 4. Those are the 4 spaces that are erroneously being added to each line of Python code that has indentation. This is the problem we set out to locate, understand, and then fix. Before we could tackle this problem, we needed to learn more about Sphinx and Python. Next, Zafar will have a brief overview of Sphinx.
Hi, this is Zafar Siddiqui of the Sphinx Whitespace project. I'm going to be spending a little bit of time talking about what Sphinx actually is. As you can see on this page, Sphinx is a Python documentation generator. It takes several source files and it integrates them into an interface that the user can very easily follow. As we can see on this page, several users have already used Sphinx to create documentation, and we can see it's a very popular product for this purpose. I remember as a student in the introductory computer science classes at Loyola, namely Comp 150 and Comp 170, I would always wonder as to how these tutorials that we used in class were being created. It just so happens that our professors used Sphinx for this purpose. One such example was the hands-on Python tutorial that we used in our Comp 150 or Introductory to Computing class. As we can see as we click through these links, the source files have been integrated seamlessly into a very beautiful looking documentation that users can benefit from. In order to better understand Sphinx, we as a team created a very simple documentation. We were going to deal with how Sphinx handles code. So we figured that it'd probably be most helpful to start by creating a very simple documentation that integrates code in several different ways. And so as you can see, we're in the Sphinx test folder, which is on my desktop. And we have an index.rsc file, which is the root file for the directory. That's where all the links are for the other files that are being integrated. And then we have a code.rsc file, which happens to be the only link in our simple documentation. And the code.rsc file includes the code2.py file. And we'll talk a little bit more of how this file is being included a little bit later on in the video. But if we click on the HTML link for the index file, we see that it's a very simple documentation, but we can see 3 different ways of how code was included by Sphinx. The first 2 are in the actual code.rsc file, and the last one was included from the external .py file. And as you can see, some of them are numbered, some of them are not. And we're just doing this in order to better understand Sphinx and to figure out how we were going to actually solve the problem. Now I'll hand it over to Nick to give us a small introduction on Python.
Hi, this is Nick Giranda with the Sphinx Whitespace project, and I'm just going to talk briefly about Python, as Python was the primary language in which Sphinx was coded in. Python was developed in 1991 and is a free and open source language. Python is primarily concerned about readability, and it attempts to emphasize readability a couple different methods. One, it will often use keywords where other languages might simply use punctuation. Also, and one that I found was particularly interesting when attempting to learn the language myself, it actually uses indentation as part of the code. Now, while writing code in other languages, you would be expected to use indentation for readability's sake, it actually changes how the code is read in Python, thus enforcing that you would be using indentation and hopefully increasing your readability. Another thing that I thought was interesting when learning how to code Python was that there's currently two different versions of it. There is version 3.4.1 and 2.7.8, and even simple commands are actually different between those two versions. The one that I noticed right away was the print hello world command. In 2.7.8, when you use the print hello world command, all it takes is print, then the string hello world. When you use it in 3.4.1, it requires print, then parentheses, the string hello world, and then end parentheses, which caused a little bit of difficulty when I was going through the tutorial until I learned that there was actually this difference. Just one last tidbit about Python before I give it up to Curtis here. It's actually used in the installer for Ubuntu, which I thought was kind of interesting because that was the primary OS we used in a virtual box when we were working with the code for Sphinx. Well, that is all I have for now, so I will go ahead and turn it over to Curtis.
Thanks, Nick. I'm going to briefly talk about free and open source software and our teamwork. As mentioned, we are beginning computer science students. Our experiences with Python and free and open source software are limited and new. Thus, when considering that Sphinx and Python are built on the strengths of many people and not-for-profit, we decided to take a similar approach to our teamwork. We specialized in responsibilities. For example, Zafar and Nick's computers were better able to run the virtual machine and Sphinx rebuilds. I offered to lead scheduling and communication. We met on a regular basis to check in with one another's progress, as all three of us were working toward better understanding of Sphinx and Python, locating the issue in Sphinx documentation on GitHub, and then correcting the issue using Python code. We met in person, using Skype, on the phone, and with Google Hangouts. We used Google Drive, Virtual Machine, Camtasia Studio, and many internet searches for our troubleshooting. Like free and open source software development, there was a great deal of experimentation, exploration, and use of community resources. I am now going to turn it back over to Zafar, and he's going to talk a little bit about how Sphinx works.
Hi, this is Zafar again, and I'm going to be going through how Sphinx works in a little bit more detail this time. I will also be outlining our process and how we went about trying to solve the problem and the difficulties we encountered before finally being able to solve the problem. This is the homepage for the Sphinx Developer's Guide. We went through a lot of this in the introductory video, so I'm just going to skim it really quickly right now. The first thing is we had to create a repository to host our project. We were initially using GitHub because that's what most of the class seems to be using, and we did use GitHub for most of our project. However, at the end of the project, we realized we wouldn't be able to send a successful pull request on GitHub because the repository uses Mercurial and GitHub does not support Mercurial, so we kind of switched over to Bitbucket at the end and submitted our pull request through our repository on Bitbucket. This was our homepage for our GitHub repository. As soon as we started the project, we thought that we would go to the writers class in the Sphinx folder and manipulate code using the html.py file. It is responsible for writing the contents out to an HTML file, which we thought was where the problem lied. However, we tried changing this file a lot to no avail, because we always got an error message saying something was wrong, it wasn't going through. So we decided to start exploring more into the code. And so we went through the builders folder, we went through the directives, we really went through a lot of Sphinx code before shifting our focus a little bit. We realized that Sphinx was heavily dependent upon the docutils program for generating documentation. So we researched more into how docutils work. The first step that docutils uses is it reads the document. And once it reads the document, it passes that to the parser. This is where the real important stuff happens. The parser analyzes each file and creates a node tree representation, or what docutils calls a doc tree. So each file is read into a hierarchy of elements, and this is an example shown here. This is the defining characteristic of docutils. And oftentimes in Sphinx we would come across different types of nodes, but we didn't really understand what a node meant until we realized how docutils handles files and creates a doc tree out of them. After parsing the document, it transforms the document to further modify this doc tree, and finally it writes the document out. After going through all of this, we realized that we would not be able to extend docutils in the short period of time, 3 or 4 weeks. So we started looking more specifically into how Sphinx deals with line numbered code, because we realized that the problem was where Sphinx handles line numbers, because in the code blocks that don't have line numbers, we don't have the extra white space. So we researched how Sphinx deals with line numbers, and we came across a program called Pigments. Sphinx uses Pigments to handle all code. Pigments is specialized in highlighting syntax of different languages, but it also has a functionality to add line numbers to the code, and this is what Sphinx uses to add line numbers. So we went through the code in Pigments, and we came across the function that creates line numbers, and we realized that it has an array, or it has a list called lines, and it would probably be pretty easy to modify this array to strip any leading white space and solve our problem. So this is what we started doing. We started creating small functions to manipulate the array, and we installed Pigments for this on our desktops, and we were running tests on it, but nothing seemed to work completely. So this is the point where we asked our professor, George, as to what he thought of our possible solution. And that's when he pointed us all the way back to Sphinx, from where we started really, and he pointed us to the directives folder, and in the directive folder there was a file called code.py. It was a file we already had looked at, but we had missed where the files were being read. And if we look carefully, there is actually an array being defined called lines, which has each single line. Again, something we were looking for throughout the code, and something we could easily modify to create a function that stripped extra white space. So we ended up working on the literal include class, but we also realized that there were problems in the code block directive class, and so we added similar functions to both of these classes. Now I'll hand it over to Nick to explain some of the code we added.
Hi, this is Nick Giranda. I'm going to go over the actual changes to the code we made in Sphinx in order for us to include a dedent option with the literal include command. Just to refresh, the literal include command is a command that allows the user to specify a document of code to be included directly in their documentation that they're creating with Sphinx. Now, these literal includes have a number of options associated with them, things like adding line numbers, or changing the tab width, or just letting Sphinx know what language you're using for highlighting purposes. To that, we wanted to add a dedent option, which would allow the user to specify the number of characters to be removed from each line at the beginning. So when we were pointed in the direction of where literal include was in the code, we came upon this dictionary of options, and we added dedent to the top of it. We made it an integer so that that could be used to specify the number of characters to be removed. Then, a little bit later on in the code, we can actually see where Sphinx is reading from the file given to it by the user. You can see here it opens up a stream reader with that file name. Then it creates an array of strings called lines from read lines. And what we've changed here is if the dent is in self.options, which is basically the collection of options given to Sphinx by the user for a literal include, we shorten it down, well, we shorten each line down by the number of characters specified by the user. And we do that for, basically, you can see here for every line from 0 to the length of lines. We do have an if-else statement here, and that's just because we figured that we did not want to delete any lines. Even if the user specified a number of characters greater than were in the line, we didn't want to remove the line entirely. So this here just checks to see if the length of the lines is greater than or is less than or equal to the number of characters specified to be removed by the user. If it is, all we remove is the length of the line minus 1. If it isn't, we remove the number of characters specified by the user. As such, if there's simply a line break in there for readability purposes or something of the like, it should still stay. Well, that is basically all I have for what we changed in the code directly. This only is for the literal include. We suspect that similar changes could be made when including code snippets, but that was outside of the scope of our project at this time. I will go ahead and let Curtis finish up our video. Thank you very much.
Thanks, Nick, for going over the changes we made to the code. For our final part, I'm going to go over the challenges and benefits of free and open source software development. So first, what are some of the challenges that we faced? Well, one was, where do we start? It was a little overwhelming. Do we really dive into Python? And since none of us were expert programmers just yet, do we learn everything we can about Sphinx? Do we ask around and find out more about this issue? Do we contact the experts? There were a lot of questions as to where do we go because we were starting from scratch. Another challenge was we did find tutorials for Sphinx and writing extensions. However, and we were excited about them, but then when you go through the tutorial as a beginner, it's like a whole other language. It's like those tutorials were not written for beginners, so that was a bit of a downer. Another challenge was there's no dedicated on-call team, so Sphinx doesn't have an email address necessarily or a phone number where you can just contact someone and say, hey, we don't like this, or we need some help. You kind of just have to figure out the resources and community and developers along the way. Another challenge is that guessing can be frustrating. So there were many times where we couldn't figure out what this folder was in Sphinx documentation in GitHub, or we didn't necessarily know a lot of the Python code that we were looking at in Sphinx. And as a team, we would kind of bounce ideas off of each other. It didn't mean it was easy, though. Code notation in Sphinx documentation was not always present nor helpful. So there were method names, functions, variable names. We did not know what they were referring to. We would read it and read it and read it and just sort of look at each other like, sometimes we just laugh. I have no idea what that means, or what's that variable doing, or maybe if I knew more about Python, I would know what that means, but that was also a challenge. And a sixth challenge would be the original coder is not necessarily available, so maybe we do find the area that is causing this white space issue. Well, if we don't necessarily understand the logic behind the code, it's not like we one, know who wrote that code, and two, even if we did, we were able to get a hold of them. And finally, this is just kind of funny, but there's no money. Yes, we're students working on this, but free and open source software development doesn't necessarily pay it directly. But as for benefits, a lot of exploration leads to a lot of learning. And so, yes, maybe we felt like we started from scratch, but we also did a lot of exploring and trying to find answers along the way. Another benefit would be, well, without tutorials, you do a lot of troubleshooting. So there's a lot of guessing and troubleshooting and sort of just journeying down one path until that works or doesn't work. And it didn't work a lot of times, but you sort of develop tools for troubleshooting when working on these things. Likewise, discovering ways to locate answers and resources. So we did a lot of searches online. We looked to each other. We reached out to a couple professors. We made an online post to developers of Sphinx asking if this leading whitespace issue was known and if it was being worked on. And it just so happens that Dr. Harrington had made a very similar post 4 years ago with no response. And we got a response 3 weeks later from a developer of Sphinx saying that they were aware of the issue and they were working on it. Guessing can be fun and funny. So there were moments where we would just guess and guess. Maybe what does this code mean, or where in all of this code is this problem? To the point where we would just laugh because we really had no idea what we were doing a few times. So beyond the frustration, there was laughter and teamwork. One great thing about not understanding somebody else's code is that you can make new code. You can sort of cover the issue that someone else made. So we had some conversations about that. Do we write brand new code, or do we go in and try to change someone's code if we can even find it where this issue was? And likewise, being part of the solution for free and open source software, sort of being able to add to something is rewarding. Not only that, but you can build a network. So we worked as a team and we figured out each other's strengths. That was one way of building a network. But even online and with professors and other people, other developers, you're able to start building a network of programmers. And finally, maybe there's no money, maybe there is. Either way, it's great for your resume as a developer or a programmer. And when we figured it out, we felt really, really good when we could actually get Sphinx to build and not have this issue anymore. So that concludes our video presentation. I'm Curtis Main with Zafar Siddiqui and Nick Giranda for the Sphinx Whitespace project at Loyola University Chicago, and we really thank you for tuning in.